through a lot of the new beamlines. So, you can send in large user samples, and we will be able to host them. And then we're going to test, basically expose them to the X-ray beam, and they can then, get results. And the infrastructure that is inside the IT has also grew with all these extra beamlines. So we will have more virtual server. We will have more storage, petabytes of it. And then with that expansion, on top of all this, we probably will be able to offer live streaming data, okay? That actually gives you benefit for a couple of things. One is that you can probably observe remotely the test result, and also able to change because it's live. We are streaming it to you through the IT system. We will be able to allow you to actually affect the experiments remotely. Okay, although that we will be loading the sample manually into the system for you when you mail them in. One of the things that we are talking about is that you will be able to see the image that you just capture, and then you can change the course of your experiment instead of waiting for things to happen and you get it back in the mail, and then you figure out that what you need to do next time when you come visit. Okay, and so overall with those new beamlines, we're also changing the infrastructure of the IT as well to back it up. Okay. All right, that's pretty much finished the new beamline. So any questions there?
Thank you, Alan. Does anyone have any questions?
Yes. Yep.
Okay. Well, in that case, let's move on to the next one. Thanks again. Yeah, David.
Thank you.
Right. Oh, well, hopefully this will be the last time people have to see me today. Oh, I just need that, yeah, unshared. Thanks. Screen to share. Okay, hopefully everyone can see that now. So what I was going to talk about today, it's just a bit of a, what do you say, bit of a list of things we've been thinking about that we're moving forward with our control systems, and also, some things are actually in motion at the moment already. So some of the opportunities we see for improvement, certainly around cybersecurity, which came up earlier. We know we need to go and review the network architecture, venture further into this virtualization of hardware, upgrade of the entire Antares control system. We also, in part of that, look at upgrading the control room and making spaces and things for the actual equipment. Unification of the Vega Sirius into the EPIX control system. I guess probably something that hasn't really been, everyone's probably assumed that we haven't really probably spoken about specifically. EPIX for us, I guess, is our patchwork quilt that we want to bring everything together. Sure, there's other kind of flavors of control systems and things out there, but that's the one that we want to try to standardize and stick to. Look at our archiving to get an easier maintained system, templates, technical staff engagement, and development platforms. So, as I think I might have alluded to in one of the previous slides and talks, we know we've got some issues that we've kind of we've inherited as part of the legacy of the initial systems. When the Antares control system was first put in place, they had its own dedicated network, and at some point that network was joined to the corporate network, and then we've got this very flat LAN structure. And I think one of the reviews that we actually had with Nick House Group, they ran a bit of a system check on us, and some of our biggest vulnerabilities didn't actually come necessarily from our computers, but because we shared that subnet with other tenants in the building, they had systems which were actually out of date and had vulnerabilities and things which incurred, you know, in past affect our systems and the level of ruggedness of our security. So, and part of this also, we are trying to be better, we say, actors in this space and trying to engage with those resources within the organisation, because we're absolutely not experts in a lot of what we're even talking about today. So we're sort of depending on the community and those around us to help hold our hand and guide us a bit as well as our own initiative. So one of the areas that even the cybersecurity comes into, which also impinges upon our regulatory licensing requirements, we're likewise trying to make our systems straighten out the way that people can remotely access, because the Sirius and Vega systems came from a supplier, and the supplier had a particular way which they normally manage and maintain these. It's opened up the system in its initial phases in a way that different operators can get in, and it's got lots of flexibility, which is great. They can do a lot of things. They could run remotely if they wanted to, but under our licensing arrangement, they're not allowed to, because we have to ensure that we've got, you know, who is actually in control of the system, that they don't create a dangerous situation or radiological effects for people who might be walking around the facilities that they're not aware of because they're not actually present in the facility. So some of those initiatives in the kind of initial suggestions are even things like starting to make access to some of these networks through the use of jump servers and things, where we can still do two-factor authentication of ANSTO employees coming through the normal system, leveraging off what's there, and then using a system which is joining between the two networks that they first log into, and then can sort of pass through and do what they need to. And that way we can also manage the tools, and if we need to, we can pull the plug and get rid of all control to those machines. So you can sort of see our kind of current access regime, and hopefully just an example of what we go to with the jump server. Network architecture, as said, this has come up a few times. We really are suffering from our previous iterations, and I think I know I've had a number of conversations with our Synchrotron colleagues who have been really great and insightful in some of this, and I think we're trying to learn a bit from some of the lessons that you guys have learnt and some of the structures that you've gone to try to think about how we might start breaking up our sections of our EPIC system into subnets, utilising gateways, archivers specifically for some of the subnets, and facilitating this communications, but also giving us isolation through the networks. And hopefully this also drops down on the amount of bandwidth which has been going on in some of the actual subnets themselves to make them a bit more responsive. Virtualization of hardware. So most of our systems currently, or our IOCs, are running on physical boxes and machines. We've definitely had our periods of times where we've had a machine go down and recovery process, you know, even if we get it sorted out in a day, it's still a long period of time. Certainly doesn't have the, you know, the ability to kind of restart a virtual machine and all these kinds of things, which can happen in space of 10 to 20 minutes or so. I think I've heard from some of the reports down at the Synchrotron there. So we've invested in 2 servers, which we're likewise working with IT, and once we get hopefully all the network infrastructure straightened out, we'd like to get the virtualization of some of these systems straightened out and start deploying some of the IOCs which can be virtualized onto those systems. As part of the upgrade at Antares, it will be very nice to eventually see most of our VME gear removed. It's very expensive for us to kind of maintain, and a lot of equipment now we just can't get anymore. As I think I said earlier, we had a processor board which died. We had to buy a second-hand one off eBay, which was even like 1,500 Australian dollars, and that was cheap. That was really cheap for it. So it's it's definitely a liability for us at this point, and I think the sooner we get to a more accessible platform that we can sort of integrate in, the better. And I think that sort of themes come through a few times today, actually, and I'm learnt a bit about everyone else's kind of idea of what end of life is and the timeframes that everyone else is working in, which is very interesting. So the Antares control room, we've got the original thing. Sorry, all my little diagrams have disappeared out of this one. But I did have we've got a set of racks and a control desk at the moment, which is all very open and terrible. What we're looking at doing is actually having a separate server room, which where we can, because we don't effectively humidity control our main computers and things at the moment. So I think that's another side of things where we're hoping to fix up to get the running environments more appropriate for some of these, hopefully more reliable systems that we're setting up, and making sure we have all the appropriate like UPS infrastructure and everything to make that much more reliable than what the current sort of level of vulnerability is. Yep. So unification, Vega and Sirius. So as we mentioned earlier, these ExcelNet systems which run on our Vega and Sirius, they utilize these tags. This is what the tag looks like, TPS2K01 GVM voltage read. So this one's actually reading back the terminal voltage of the accelerator. That's all very interesting and valuable information, both for facility signage, displays and things, which we do have this sort of coming through at the moment, but also for our long-term fault analysis if we do have breakdowns or we want to see when something's happened on the facility. So we want to try to get all that information into our EPICS archiving systems. Coming back the other way though, if we can still communicate through EPICS and then push it to tags actually within the ExcelNet systems, then we can also build other kind of third-party applications which are going to do, facilitate controlling of the machine for some of the experimentation. For example, for nuclear reaction analysis, where we have to keep on stepping the power or the energy of the beam so that it reacts deeper and deeper in the sample, that we can sort of produce depth profiles. So we would need to kind of continue to mature our abilities in that case. And Jian's been doing a very heavy task at the moment, trying to get all the tags from both the Vega and the Sirius machine into the thing. My apologies if people can hear someone's got a whippersnipper going now, which is awesome timing. Archiving, so I mean, I don't want to preempt. I see there's a talk coming up after, but I mean, I think we want to look towards going to, I mean, I find it very interesting in the conversations about the maintenance. I won't talk too much about this because this is going to be spoken about later, so I'll just let that one go. Templates, more canned solutions where possible. Objects we can just be configured just such as standard control systems for vacuum management systems and stuff like that. So it would be great if we can mature most of ourselves into most of our solutions in some kind of reusable object kind of arrangement, as opposed to doing everything bespoke from beginning to end each time. So, and I think that's going to be like a maturing of our capabilities in the group. As I think I said in the earlier slides, we've got 2 people associated primarily as our computer systems and controls, and we've got technicians who were traditionally sort of in the electrical electronics and microcontroller kind of space, where we're kind of relearning up and trying to reskill so we can interact better with the controls and do integration better. So, and this sort of gets into typical staff engagement. So we want to see a wider training in our controls within our group and further understanding. Continue reviewing and building local standards to help us do that in a manner that we're all working in the same direction and got a unified understanding of how we should be going. And we'd really like to kind of keep on boosting so these greater engagements with the local community. So we really do want to get to know the different people at the various labs and that certainly helps us to have some friendly faces to go and sort of even spitball with and try to kind of help fill in some of the gaps that we might have. And I'd certainly like to see us even getting to a point where we have like almost like a peer review of some of the bigger jobs that we do. So we identify opportunities for improvement before we get too far invested. Development platforms, it's kind of, I guess it's always kind of interesting. I guess because I'm probably more in the sort of gadgets, electronic-y kind of gadgets space. I mean, I find it very attractive. I keep on seeing these very cheap controllers on the market, which can apparently run, like the Raspberry Pis would run Raspberry in, and I believe they're being utilized. And Matthew did a good job of actually setting up and running an IOC, doing some kind of communication with the IO with one of the Raspberry Pi 4s. And like this little kind of fella to the side here, as I think I said earlier, we had one of our VME crates go down, which had 2 processor boards in it, which does all our AMS data acquisition system. So something just like that little board there, which is a hell of a lot cheaper, has got the 2 processors, or 2 cores built within it that can both run separately. I think it even runs like a Python interpreter language in one processor and run real-time kind of measurements on the other side. So it kind of lends itself to some development work that we might look at with, say, beam profile monitors, where we want to be running in real-time sampling at a really good rates, producing data, and have another processor which is actually consuming the data and actually facilitating all the communications back up the other side. So yeah, I think as far as the integration side, we'd really like to kind of learn and get some good sort of capabilities within that area as well. But that was just a brief overview. If anyone's got any questions, please go ahead.
Quick question, if no one's going to jump in about this, is to everyone with the Raspberry Pis. They're cool and stuff, but we're finding that they're not, they don't really cope with power outages very well. So just, you know, we're just running with the SD card. And even if we get a good SanDisk SD card, there's only a certain number of times they can survive a unplanned shutdown before the SD card corrupts. I don't know. So I mean, we use it for fun and we use it for things that aren't all that important, but I don't think we'd want to use them for anything serious.
Oh, that's interesting though. So is that sort of more like a corruption, like the operating system doesn't shut down properly, so it just sort of, yeah. Okay.
I found that with Raspberry Pis that I use at home as well, that after a while they just, the card gets corrupted. The image gets corrupted, and then that's it.
Oh, right, interesting.
I'm wondering if that's a brownout situation where the power doesn't go off quickly enough.
It's likely with the way our power runs sometimes. Yeah.
Also, by the way, there's no guarantee that if you buy more industrial equipment and or scientific equipment that it won't suffer from something similar, because we've had situations where things have been turned off and you turn them back on again and they just don't come back.
Yeah, that's we have a lot of problems after Christmas break.
Shutdowns, yeah.
We had a bunch of micro OCs that had SD cards, and I know we went through, not me personally, we went through an exercise of cloning them all, and I think we had a couple of backups for each micro OC. So if the SD card got corrupted, we could just drop in another one.
Yeah, I've got that. We've done that for. Got some other things that just boot off a USB stick, and we've got plenty of copies of those, but we've never bothered for the Raspberry Pis because they're not really, they're just displays that we can rebuild.
Stuff,
yeah. I guess the good thing there, though, if you kind of got that kind of, when you say in-depth kind of thing, with at least having something like the Nagios system to sort of back you up, as long as the main thing, you know, it's gone down as opposed to going down. I know the situation where we were looking at using it within was actually for like a liquid nitrogen filling system, where we didn't really need it to have a lot of capabilities, but for just something which is going to turn on a few valves and give some update information on the status of a Dewar, and that we thought it might have been a reasonable kind of platform just to sort of try a few things out on.
I assume that maintenance one is a commercial system. Was it just Navios?
Sorry, Nagios.
Yeah. Is that under like? What's the licensing like, or what sort of?
I think
does it cost money? Like us?
Oh no, I think it's free, the one they've got.
All right, I'll have a look.
If Andrew Downs is there, he'll be able to fill you in actually.
Yeah. All right. Cool. I'll have a look.
Yep.
Yeah, it's free. We do. It's all open source.
All right. Awesome. Thanks.
I was just looking at the Arduino Portenta. That looks quite interesting. The ability to have the high-level stuff and the real-time stuff tightly integrated.
No, I thought it looked worth having a bit of a tinker with, so we sort of got one in.
Excellent. Well, let me know how it goes. I'm very interested.
Yeah.
All right, thank you. Thanks, Dave.
No worries.
So the next one up was supposed to be Nick, but he got called off, unfortunately. So Alan has agreed to finish his first talk of the day, because I think he only managed to go about halfway through, and I think it looked very interesting. So, Alan, you want to finish that?
All right. Okay. Well, I apologize first, guys, that you have me back again, and I'm sure that hopefully this is the last time. Right. So first of all, given this opportunity, so what I will do is just going to go over my old footsteps here a little bit, and just want to highlight some interesting area. Want to expand some of them. Across the morning and this early afternoon, we have talked about naming conventions and things like that. Don't know whether you guys are aware of the effort that Andy and Andres is working on a piece of software called CSBS. And with CSBS, they actually, it stands for Control System Breakdown Structure. And what we do is that we basically break down the all the control signal requirements, and then we put it into this database system, and it will generate all the standard names. And then with those names within the database, then we put it across to things like we got a piece of software called Soken E3 at the moment, and this piece of industrial strength software for CAD drawings and all that, especially for electrical drawings, we are able to use those informations to generate wiring diagrams and so forth, and also they can model 3D pictures and putting in all the diagrams or pictures that it generates. Now, with that said, that then can be shared amongst all the IPTs, the teams, and they will get the standard information. And it's a single point where we actually hold all the names in one place. The same CSBS software can also help to generate the engineering GUI, and those names will get transferred across to the GUI generator, and like Qt, and then they then actually generate the GUI for us. And so at least that this way, all the names are consistent. And we did notice that there are, of course, some scientists would like to actually use nicknames, for example. And this is an area that I think Andres and Andy are looking into and see whether we can improve it. But certainly, if you're interested, you can talk to them about the CSBS. So moving down to where I highlighted the refurbishment program, I just noticed that about cybersecurity, and I wanted to expand that a little bit. Currently, in the synchrotron, we have this refurbishment program where we touch on older equipment and whether we are actually considering whether we should refurbish them, replace them, or whatever. But however, I want to highlight that the cybersecurity consideration never made it into our assessment for the refurbishment. So none of the equipment, such as the, like for example, if we have a PC with Windows 95 on it, it never actually trigger any decision making based on that. Okay, so I think for us, the takeaway is that from the meetings that we have today, is that we definitely need to add this parameters into our considerations during the refurbishment to assess the equipment, to see even if everything seems to work, but just simply the fact that it's Windows 95 is too old, it poses a cybersecurity issue, that we should replace it. Okay, and this is the trigger point where I think this we can add the consideration in. Okay, just to go down a little bit, we talk about remote factory acceptance tests, and I didn't have time to expand on this, and just want to let you know that if you're looking at the diagram here right now, and on the top left corner,
Alan.
Yes.
Sorry, can you share? You're not sharing your screen, I think, so we can't see.
Oh, it dropped out. Okay, hang on. Hang on. Did it just dropped out on that one? Is that back?
Hang on, it's thinking about it. Yeah. Thank you.
Okay. All right. Yeah. So I'm not going to hit that other button. I'm just going to let this go. The remote factory acceptance test on the top left corner, I just want to highlight that normally you have the vendor specs and the vendor issues. And of course, when you talk to them, they might have a ready-made product. But the other thing, the vendor data and also the vendor video capturing device is new, okay, in this aspect. The reason is that if you're doing remote FAT, you need to consider that whether the vendor have those equipment. And if you're doing tendering process, and you know currently with COVID-19, you should be triggering conversations with your vendor, talking about whether they have those equipment available to capture the raw data to share, and also video equipment that where you can capture videos and pictures to share to you. Now it can come at a cost to you. If you don't actually highlight that upfront, the vendor might say that, you know, if you suddenly trigger them and say, we want to do remote FAT 6 months down the track, they might turn around and charge you a huge amount of money just to have all these facilities. Okay, so just to highlight that the thing is that in this diagram there are new considerations to be put in, and you wanted to highlight them in your tender document. And of course, if you move down to the middle where the FAT format meeting and the format FAT agreement, those are now remote centric, and so they're different conversation, different amount of time that you will be spending on your FAT, and you're talking about different manpower, different costs here, and also the commitment by the vendor. If you have this upfront before your tender process is over and you trigger that, they might be able to work into the total cost of the tendering and the offer to you, knowing that if it's triggering the remote FAT, this is something that you already know what the cost is, so it can factor into your budget. And in the middle, you have the contract and you have the agreed FAT specs and all that. Again, now it have become much more in terms of the documentations. And of course, if you move to the right, you have the pre-FAT review. And now you're looking at a great amount of details. You're looking at schedules that are much longer. And so you know, longer than what we find is at least twice as long or even 3 times as long as a face-to-face FAT. And of course, you know, your normal FAT, you know, where you see the circle here, you are using Zoom, you are using camera device, you are exchanging data. This happens daily If they are actually overseas, for example, like versus Australia to Germany, you might be thinking about us in Australia waking up in the morning, reviewing the data from yesterday from Germany, and then commenting it and sending it by the afternoon. And then when they wake up in Germany by our mid-afternoon, they actually have a meeting to see what they can do while we are about ready to leave work, and then they can continue to do the work and update us for the next morning. Okay, so all this has to be worked out carefully. And then, of course, once you finalize the FAT, the remote FAT, all the data is then go behind a firewall in the repository that where we actually set up. And you accept the final results, and all the documents is done. And then finally, ultimately, you get an invoice and you pay for it. Okay, so this is the process, and it's much more arduous than a normal FAT would be. And I just want to highlight that this is the case that what we found. Okay, so I just wanted, this is the bit that I haven't really touched on, is the actual MAX and MCT schedule, and where we are at, where we are today, and what the impacts are with COVID-19. I wanted to highlight that. So what you're looking at is that we have a standard process which is in the background, okay, for the control system, and for MAX, a lot of the different parts like the MicroPro, the end stations of MAX 1 and 2, and the spectrometer, they're all at different stages because they are with different vendors, and some of them are leading and some of them are lagging behind. And however, we are all heading towards the factory acceptance test stage. Okay, now we have on the top right hand corner is the engineer and the task force addressing those things, and then behind that we got the entire team. And hopefully we will not be in a scenario that where we have multiple projects running at the same time that we run out of manpower. And initially when we planned for this is that we hope we were going to be able to execute this, and then the task force will be able to move along to the other projects such as MCT following. Okay, but this is how it turns out, because COVID had changed everything for us. Okay. And on the side, we also have a data acquisition synchronization project running for MAX, and the synchronization project actually is wide-reaching, and this is all talking about the timing sync up across all the projects and the centralized timing, and we are doing that, and the control team here is doing this upgrade, and we build our own little gadget. Then we commission it and deploying it across all the beam lines. So accuracy and also timing, frequencies and all that are all standardized because of that. And data acquisitions based on the timing also, when I mentioned about the data streaming earlier on in the other talk, is that they also affect the data streaming, and all the timestamp metadata is all going to be going through this data acquisition system. So we also have the slew scan project, and the slew scan project is that we actually trying to have multiple trajectory computed, and then it go into the motion controller, and then the motion controller execute this trajectory, and then while you have a large data detector sampling the data, this thing is executing a highly complex motion control sequence, and this is something that we're working on. The team is working towards the goal, and it's done on XAS. And if it's successful, and we would deploy them across all the other beam lines as well. So where are we with MAX? Now, MAX control schedule originally is what you see here, okay? And I wanted to show you that is because this was already at the beginning of the year, just after COVID-19 hit, this was our best case scenario, okay, that we wanted to do. And as you can see, there's a pretty typical waterfall timing, okay. We actually have most of those stuff in red. We are heading towards them and we are doing them. But however, with COVID-19 dragging on for Melbourne, and also now European COVID-19 is like, France and Germany, they're shutting down. In fact, we are once again could be in jeopardy here, okay? But however, we have introduced remote FAT here. And so some of those timelines, although they are dragging, they roughly shifted initially as bad as like 4 months behind. And now, they are gaining back. I think the worst case we are thinking now is roughly around 2 months delay, okay? So we're still aiming at that red line here, 2021, middle of the year, where we can actually do max and doing day one commissioning. We have day 365 a year later, where the whole system is fully commissioned, and then it will be ready for user. Okay, and the next one is MCT. The same MCT I mentioned that is actually a simpler beamline. Okay, so we have a single vendor, okay, Axelon from Germany, and they are delivering the PDS system, and they are heading to factory acceptance. And we will be doing a remote FAT with them. It's about to happen. And the end station is a little bit behind, but we are actually progressing them, and we are quite confident that all this will be in place when the time that during the install. And on top of this, there's the GUI to control the positioning of the beams and so on and so forth. This is a side project that the control team is also working on. And if you look at the diagram, it's involved heavily with EPICS and all the edge detectors like PCO edge detectors, and also the LAN on the right-hand side on that diagram, where the IT system for streaming the actual data streaming and image. And this will be the first project that will try that, and if it works, the system that we put in will be deployed for all the other beamlines as well. And again, this is the MCT control system schedule. Again, is the best effort at the beginning of this year. And again, it is very similar in terms of timing. We initially saw roughly around 6 months delay, and now is improving. And we are currently in just stepping into November now. And so most of the DCM and the where it says that site acceptance test, you can ship that into next year. So that's what we are talking about 2 months to 3 months delay into the early part of next year. And then we will be still heading towards the middle of the year, trying to get the code commissioning done on day one, and then 365 at the 2022, okay? Unfortunately, like everything, COVID really threw a spanner into the works, and we don't really have as much as you can plan. Is very difficult to see a day-to-day when we coming out of lockdown. France and Germany are going into lockdown, and traveling is not possible, and we have to do so much more work into getting all the documentation ready, and also at the same time executing the thing is like FAT is going to take twice as long, and manpower on both sides, the vendor and ourselves, have to be fully committed, and also the resources are locked in for much longer for that reason. Okay, so that's pretty much finished my talk. Hopefully that didn't take that long this time. Any questions? Okay.
So you said, sorry, Ellen, I've got a question. It's that's also based a little bit on the presentation that that Preeti gave on one of the forums. How, if I understand correctly, you need a contractor to come in to install the LED hutches.
That's right. Yes.
So how are you planning on resolving that if they can't fly in?
Right. So this thing has been talked about a lot, and initially that is only a contractual reason is because of the warranty issue that the original manufacturer of the hatch is unwilling to let go of that, not installed by them, because they wanted to guarantee the hatches is done correctly, okay? And they want to be on site. And so there was actually a bit of back and forth and saying, and we want them to have a local team that who can actually install the hatches for them. So what currently has happened is that the hatches been manufactured in France, and they are already on the ship. They're coming, and they relented that because we insist that the thing has to be achieved at the end of this year. Okay. Starting the installation and finishing early. And so allowing all the other timeline items to move forward. And so they have engaged with a local company called Lycopodium. And, but they actually have since then given a bit more freedom to the Lycopodium to do this. And they agreed to guarantee their work, so that the warranty on ourselves, when we accept the hatches being done, and our acceptance will be serviced. If there's a warranty issue, it will be serviced by the French people, okay, the vendor. So you see, this is more likely as a contractual thing, and the skill set. Yes, we do need them here, but there's not something that you cannot do remotely. But again, they just need to get organized and understand what the problem is. Okay.
Okay. Yeah. Great. Thank you.
Yeah.
Well, any other questions? Okay. Well, we're just on time.
All right. Thank you.
Today, probably to take a break for the afternoon tea, and yeah, I'll see you back at 10 minutes past 3. Thanks, Alan.
Thank you.
Thanks.